In this video, I'll introduce you to Clarion 6.1, a software package for building Clarion simulation. Clarion 6.1 is currently the most complete and up-to-date implementation of Clarion. It is implemented as a C# library and distributed as a DLL. This means that you do not have access to the source code. However, the package ships with documentation, as well as several detailed tutorials and examples. To set up your development environment, you will need to download and install a C# IDE. Clarion 6.1 has been tested with Mono and Visual Studio, so it is recommended that you use one of these. You may download Clarion 6.1 from the Clarion Cognitive Architecture website. Once you've downloaded and installed everything, you need to create a solution and add the Clarion DLL as resource. Let me show you how to do this. For this demonstration, I will be working with Mono. The first thing we need to do is to create a solution, which is simply a container for various projects that belong together. To do this, I simply click New Solution in File. When I do this, it immediately puts me into this New Project screen. And for this demo, we'll just pick Empty Project. On the next screen, we can name our project and also give our solution a separate name. I'll name this project Clarion Demo. As you can see, the solution inherits the name of my project. But since I want to house all my Clarion simulations in this solution, I'll call it Clarion Simulations. You can of course tell Mono where you would like it to create the folders for your project and solution. When you're ready, simply click Create. We've now created an empty solution. The next step is to add resources to our solution. To add a reference, right-click on the References folder under your project and click Edit References. Because I tested this earlier, the Clarion library appears here, but I'll show you how to find it from scratch. When you first want to add the Clarion library, you have to click .NET Assembly, go down to Browse, and then navigate to the location of your Clarion DLL. Once you've found it, click Open, and it will be added as a reference. In addition to the Clarion library, we need to import the system package. You can access this from the Packages tab. When you've added all your references, simply click OK. At this stage, we can begin writing some simulation code. Clarion 6.1 streamlines the simulation setup. It provides objects for nearly all relevant constructs. The general workflow is that you begin by specifying the task environment, including features and other objects in the simulation. You initialize the agent, and then you provide some mechanisms for the agent to interact with the environment. You can get a basic simulation running very quickly. demonstrate this, we'll walk through the first sample shipped with the library. The sample demonstrates bottom-up learning using the rule extraction and refinement algorithm. The task is to get an agent to say hello when greeted and to say bye when parting. For this demonstration, we'll first read the sample code and then run it to see what it does. The first step is to create a copy of the sample code in our project. The name of the file is Hello World. So I just copied over all of the code in Hello World into my demo file. Okay, let's begin analyzing the code. We're going to build an agent that has one network in the bottom level of the ACS, but no explicit action knowledge. And we're going to show it many salutations, either hello or goodbye, and based on what it responds, whether it says hi or bye, we're going to give it rewards or punishments. At the top of the script, we declare all the resources that we'll be using. The bulk of the simulation code is in this main method. The code contains both commands for the simulation and logging commands. So I'll point those out for you. On line 18, you can see we just display an initialization message. Then on lines 20 to 22, we define some task variables. Line 24 through 27 is again set up for the output. And then we get our first code that uses an object from the Clarion library. In the Clarion library, there is a world object that maintains a lot of information. In order to create various constructs, such as agents, features, that is, dimension value pairs, actions, chunks, etc., we interact with the world object. On lines 29 and 30, we create features that will allow the agent to perceive salutations. One for hello, one for goodbye. Next, on lines 32 and 33, we create action chunks for possible responses. The agent can either say hi or it can say bye. Once we've created these basic elements, we initialize our agent called John on line 36. For this simple task, these are all the features and chunks that we need to initialize ahead of time. So we can start specifying how our agent called John processes information. On line 38, we initialize a queue network in the bottom level of John's ACS. Then we configure the network on lines 40 through 44 by specifying which features are its inputs, the two salutation features, and which features are its outputs. These correspond to the two actions that John can perform. Once we're done configuring the implicit decision network, we have to tell the agent object to wire it up in the ACS. We do this by calling the commit method on John on line 46 and passing to it the network that we just initialized. Once an object has been committed in this way, we can only make limited changes to it. These changes include setting parameters. On lines 48 and 49, we set the learning rate for the network, and we turn off rule refinement. That's just a simplification. Behind the scenes, the system knows that we want this network to be placed in the ACS. That concludes agent initialization. Now we can get to setting up the dynamics of the simulation. The environment here is very simple. A salutation is presented to John, and based on John's response, a reward or a punishment is returned. On line 55, we create a random number generator because we'll be presenting salutations randomly, and we declare variables for sensory information and external action chunks. Next, we enter the main simulation loop. At the start of the loop on line 62, we create a new sensory information object. This will allow us to pass sensory information to John. Next, we randomly sample a number such that with probability 0.5, we either present John with a hello salutation or with a goodbye salutation. We do this by specifying in the sensory information activation values for the hi and bye features we initialized earlier. Once we're done specifying the sensory information, we can pass it to John with the perceive method, as shown in line 79. Next, we retrieve the action that John chooses to perform in response to the sensory information using the getChosenExternalAction method on line 82. Then based on this action, we return some kind of reinforcement signal to John. First, we consider the case where John said hi. If in this case, the sensory information included a hello salutation, as checked on line 88, then we deem that John responded correctly. We increment the correct counter, keep track of performance statistics, and we return a reinforcement signal to John using the receive feedback method on line 95. Otherwise, we know that John was presented with a goodbye salutation, so we deem that his response was incorrect, and we return no reinforcement, or rather, no positive reinforcement. This is done in the same way on line 102. For the case where the chosen action was bye, we proceed in a similar fashion. At the end of the loop body, starting on line 126, we just specify some progress messages and display them. Once all trials have been done, we report some top-level statistics, as shown in lines 135 through 137, and we also report the rules that John learned in a bottom-up fashion. These rules are retrieved using the getInternals method on line 40. After that, we start the teardown of the simulation. This involves some final reporting, and importantly, it involves terminating the agent, which is achieved by calling the die method on line 149. This will terminate any processes that the Clarion library may have launched to run the agent. And with that, we are done specifying this basic simulation. Let's try running the simulation and observing its output. By default, Mono will run the code in its own terminal, but I find it better to use an external console. This is because, at least in the case of this sample, the output displays much better on the console. To set up a run in the console, we click Run, select Run With, click Custom Configuration, check Run on External Console. You can also uncheck the Pause Console output. Makes it so that the console waits for you to press a key in the end before quitting. But the way that this simulation is programmed, it's not necessary. So we're ready to run. Let's see what happens. The simulation is done. See what rules John has learned. You have to track down that file to which the results were saved. As you can see, results have been written to this bin folder. And here we are. John performed at a rate of 98% over 10,000 trials. And at the end of the task, he had learned the following rules. In the first rule, the condition chunk expects to see a goodbye salutation, and the action in response is to say goodbye in return. The second rule, over here, expects the input to be a hello salutation, and the corresponding action is to reciprocate and say hello. Before wrapping up this demonstration, let me show you how you can get help. One way to do this is simply to hover above the name of the method. And this will give you some basic information about the method. The other option is to use the included documentation. In this documentation folder, there is an HTML documentation database. A quick and easy way to get this going is simply to open index.html in a web browser. I find that it works best in Google Chrome. This database contains all available documentation for the various constructs provided by the Clarion library. I highly recommend that you take a closer look at the various tutorials provided with the Clarion library. This demonstration was based on the first and simplest one, called Setting Up and Using the ACS. You can find more detailed information about this sample in the file.